Okay, in this particular case, we see that we have a variable in the exponent, and so that automatically tells us a log is going to be needed at some point. Well, we can solve this one quite quickly if we simply convert to logarithmic form. So we see that we have log base 5 1700 equals x minus 3. We'll go ahead and add 3 to both sides, and we will convert to a change of base, log 1700 over log 5 plus 3 equals x. We'll plug this into our calculator, and we'll see that x equals approximately 7.62. And just like that, we've solved this question in less than a minute. Nevertheless, let's try another approach that will be more helpful when we get to a more advanced question. So we'll start at the question again, and this time instead of converting into logarithmic form, let's go ahead and apply a log to both sides. So we'll see that we end up with log of 5 to the power of x minus 3 equals log 1700. Now the reason we're taking this approach here is just to prepare us for a more advanced question that we'll see later. When we take a look, we still have our variable up in the exponent, but now we can apply a set of brackets and we can have this exponent fall forward. In the next step, we're going to see that we have x minus 3 times log 5 equals log 1700. Now, you might be looking at this and see a really quick way to solve this by dividing both sides by log 5, and that'll just bring us over to the method on the left. Nothing wrong with that at all, but if you're still watching this video, it's because I want you to see this step here. Let's go ahead and distribute, and so we're going to see this becomes x log 5 minus 3 log 5 equals log 1700. Now let's have this 3 climb up, so that's going to give us x log 5 minus log 5 to the power of 3 equals log 1700. Let's go ahead and apply that exponent of 3, so that's going to give us x log 5 minus log 125 equals log 1700. Next step, we're going to add log 125 to both sides, and we're going to see that we have x log 5 equals log 1700 plus log 125. We see here that we've got same base logarithms that are adding, and so the log laws tell us we're going to multiply those arguments, and we'll have x log 5 equals log 212,500. Now we'll go ahead and divide log 5 from both sides, and we're going to see that we have x equals log 212,500 over log 5. We now have two options, depending on what the question asks. If we're asked to express this as a single logarithm of the form log base b of a, then that's going to look something like this. X equals, and by applying a change of base, we have log base 5 of 212,500. If we're asked to express that single logarithm of the form log base b of a, we have our answer. However, there may be another form of this question where we're asked to evaluate this. In this case, if we were going to evaluate, we would take our change of base, enter our calculator, log 212,500, divided by log 5, and we would see that we have approximately 7.62, which is exactly the answer we had up here when we did it the first time. So, if the question asks you to evaluate to the nearest hundredth, then option 1, the first way where you just convert to a logarithm, is the quickest way to go. We can achieve that answer, we can evaluate this in 3 simple steps. If, however, the question does ask us to express this as a single logarithm of the form log base b of a, then we'll want to follow the second method here that we saw on the right by applying a log to both sides, following forward, following through with the algebra to get us to our final answer here, single logarithm of the form log base b of a. All right, good job, good luck, and goodbye.